Yeah, thank you, everybody. Thanks for the opportunity to come and talk to you a bit about Emerson Flexim and what we can do. And really, the goal of today is really just to give you a bit of an introduction to who we are, what we're about, and sort of a different way of thinking about clamp-on and uses within where you can use it. So that's quite right on my screen. So yeah, just a bit of an agenda for you. So just a bit of an introduction and background on me and where we are within Emerson. A little bit of background on technology, just to kind of show you where we've been and make sure we're all on the same path. And then a little discussion around cost savings, operationals, cost savings, that what clamp-on can do for you. And then a bit around the accuracies and reliabilities of what you can achieve with clamp-on. And then after that, obviously, quite open Q&A session for you guys to jump back on it. So yeah, let's kick off. So yeah, my name's Simon Millington. I've been with Flexim for 6 years. The last couple of years now with Emerson since they took over the company. But we've been within industry for 15 plus years. So yeah, but really enjoy working with clamp-on stuff, and I hope that comes across. In terms of Flexim's actually a 34-year-old business, 35. Started in 1990 by 4 R&D engineers whose passion was to build the best clamp-on meter. And as you can see here, there's been a huge amount of development of the product over those years, with some notable inclusions such as going into the world of ATEX, going into gas, going into things like recently around steam measurement as well, which is quite a unique thing for clamp-on. And then we came to the UK in 2012. So before that, it was distributed by third parties into the UK. In 2012, we came as a presence and have built up a reputation within the UK, specifically within the water industry. Actually, is one of our key industries. And then a couple of years ago, the directors were at that point where they wanted to move on from the business, and Emerson bought the business, and it fitted really well into the existing portfolio of products that they have to complete a very wide-ranging product portfolio. So that's kind of where things are now. This slide is really about showcasing that clamp-on, depending on who you talk to, has a bit of a checkered past. So this slide really is how to integrate, showcases that we're used on high critical duty applications within nuclear and power industries, and also within leakage measurement on Airbuses. So it's to give confidence that actually this isn't, a Mickey Mouse measurement. This is a reliable, trusted, well-documented method of measurement, which you can take advantage of within your various industries. And this slide always sometimes raises a couple of eyebrows. So yeah, a lot of people consider clamp-on as a check metering application. So going around and making sure flows are right. Well, actually, about 90% of our business is through fixed permanent metering. The portable option as a check meter is a fantastic tool for various sites and allowing you to check meter, but the opportunity to take advantage of it as a permanent meter, as you're hopefully about to see, can lead to significant benefits, and as a result, yeah, 90% of what we do is fixed installation. So just to recap on the technology itself, it's worth highlighting that we are not a Doppler device, although we could potentially do it. What our base measurement is transit time. So the whole concept here is we have transducers emitting an ultrasonic signal. Both of them are sending and receiving, and we are measuring the time it takes for it to pass through the pipe wall, through the medium, and measure the time it takes to do that, and then compare that against the one going the opposite direction. So in its basic form, if you think about rowing up and down a river, the one going with the current is going to go quicker than one going against the current. It's the same kind of here. That time difference itself is then we take that time difference and it's slot it into a formula that is proportional to flow rate. Once we have that, we have our base measurement, which is velocity. And then we use the parameters of the pipe to give us our volume flow, and then pressure, temperature, etc. To then look at things like mass flow and standardized gas, etc., etc. So it highlights, one, that this is, you know, a well established technology, but also it all makes the reference of the better the information that you put into the meter, the better the information that you're going to get out. So the more accurate you are with measuring the pipes, measuring the water thicknesses, etc., the more accurate information you will get as well. For those unaware, the way that the meters are made up, you would always have a transducer sat on the pipe, a set or a pair of transducers that sat on the pipe, I should say. And now that could be one or multiple of, which I'll come on to. That then runs back to a transmitter itself, which does all the hard work. And then that squeezes out an analog or a digital or a network, depending on what application you're working on. Okay. So that's the basics of a clamp-on meter, really, with various additions depending on the application you're looking at. So what I wanted to touch on is to highlight a different way of thinking about some projects and potential cost savings that you could achieve around site. I think it's fair to say that you know, one of the biggest costs that companies face is downtime. Whether that is a planned downtime, whether that is or worse, an unplanned downtime, I should say. The cost that attracts can be considerable, whether that's lost production, lost revenue, it could be labor costs, repairs, just material supplies, wastage. All these costs come into large values, and what we see is that these kind of delays and delivery productions and things can really damage customer trust and potential loss of further business. So how can Flexim, how can clamp-on technology help with this? Well, let me go back a snake. So I would imagine that some of these might ring true. So are you able to shut down? Why look at clamp-on? So are you able to shut down the process is the first question. Well, if you are, then that's great. That makes things a little bit simpler in terms of running it. But I'm sorry, two things at the same time. If you are able, if you are able to shut down it, how busy is that schedule? So are you trying to achieve multiple other things in that time frame? Where is that schedule shut down? Is it soon? Is it far in the future? Is it 6 monthly or 2 yearly? What can be done in between there and then? And how urgently do you need some kind of flow measurement on a process? What would it give you if you were able to do that at any point in the process without having to shut down the process at all or shut down the plant? So that's what clamp-on can offer you, being able to put points of measurement in place without having to interrupt process, create costly downtime, and cause downtime and costs to the business. And just to highlight that really in a little bit more thoughtful way, we kind of had a look at kind of what those considerations would typically be for a flow meter installation. So for an inline meter, you might suddenly start thinking around, right, okay, well, I need to isolate pipes and I need to potential shutdown the plant. That's the big one. So is there a cost associated? Well, yes, there's definitely a cost associated with plant shutdown and pipework installation, and who's going to do it. Then paperwork and manpower around those are further costs that we need to think about. So who's going to do the work? How much paperwork is involved? Is it a risk area? Is it confined space? Is it working at height? Is it hot temperatures? All those kind of things. Is it the medium bad? Is it acids, etc. Pipework adjustments. Do we need cranes? Do we need welding kit, anything to lift these things out of the line? What costs are those associated with it? Then the cost of restarting the plant again. And then other hidden things like the pressure drops and turn down ratios of other instruments. Are they suitable? So all of these have big costs to implement. What you typically see with clamp-on, we remove a lot of these costs because actually a lot of these don't even need to happen. So yes, we have there's always going to be a paperwork and manpower element, but the costs, where you're just clamping around the outside of the pipe is going to be significantly less to somewhere that's going to have to interrupt and put more protection in place. So what we try to look at here is what typically happens when companies look at the cost of a meter. They will look at it on a cost by cost basis. So they will go, well, here's a inline mag meter, for example, and this is going to cost me X. Well, and the Flexim is going to, or clamp-on meter is going to cost X. That's typically going to be certainly on smaller pipes. When we get into larger pipes, that's not necessarily the case, but they're normally viewed on a cost against meter cost basis. What we are trying to explain is that actually the cost of a clamp-on unit goes further than that. You need to look at that whole total cost of ownership rather than just that meter on meter cost. You need to look at the bigger picture of what that can do for you, and not just as an installation, but also an ongoing maintenance perspective as well. All those costs that I've just mentioned there are kind of aimed around the installation, but actually if you think about it from a calibration or a maintenance piece, you've then got those costs yet again, whereas again with clamp-on you don't have those. You can easily maintain and look after the meter should it require it. So these are the kind of things we're just hoping to highlight and think about going back into the real world of where we can use that. And these are just some examples of various applications that we have around the UK, from just simple cooling water but large diameter pipes in the bottom right there, through to gas distribution, which you'll see the main one in the middle there, through to high temperature steam applications on the left, whether that's utilizing our standard transit time or a slightly different method here using our high high temperature kit to allow us to stand off the pipe a little bit. So yeah, that's kind of the concept around what I wanted to show you around the benefits around cost realization. Just to tie into then around the accurate and reliable piece, I think it's worthwhile taking a bit of time to highlight what you can and can't do and what to expect from clamp-on. So out of the box, if you look at a data sheet for one of our units, we always talk about straight lengths, and we talk about profile and flow profiles, etc. Out of the box, the transducer itself that sits on the pipe, that's calibrated down to 0.3%. So if we were to say, well, I know that my pipe is exactly what I say it's going to be, I know that my medium is in a perfect flow profile, so the average is exactly right, then we could probably state 0.3%. But what this graphic in the bottom left hand corner is showing is actually we have the inherent meter accuracy, which is our 0.3, but in the real world we do have pipe geometry uncertainty. We don't know, is it carbon steel, is it stainless steel, is it pitted, is it have we got the right wall thickness, is there a liner? All these things create uncertainty around what we're trying to measure. And then we have the flow profile itself. Have we come around a bend? Is there movement? Have we got swirl or any disturbances upstream? So these are the things that are being considered after the 0.3 to build the meter up to what is classed as a 1% meter for fluids and 1 to 2% meter for gases. It is important as well to mention is our 0.15 measured value for repeatability. So repeatability can also be a really important part of a process. Sometimes it can be more important than an accuracy itself. So it's worth being aware of that one. So yeah, so then we start looking at things like disturbance distances and what they can do. So what we are looking for with straight lengths is to allow the flow profile to average out as best we possibly can. So when we're taking a cross section of that pipe, we are trying to get the best average that we possibly can. So when we look at, we get the question a lot, how much straight lengths do we need? And my answer is always as much as you can give me, because the more we have, the better. But what we are looking for is certain types of disturbances are worse than others. So, historically, the 90-degree bend was the 10 up, 5 down. Now, that's true. 10D up. We now reduced all our outlets down to 3D. But different disturbances can be different. So a valve, and when we talk about valves, we talk about control valves, really. Straight through valves cause much less disturbance. But things like pumps, reducers, double bends, out of plane bends that can introduce swirl, all these things, really we're looking for 20, if not 40D from these disturbances. But however, in the real world, we know that might be okay on a small little, 1 or 2 inch pipe. However, when we start getting into the big pipes, in the real world, that's not necessarily achievable. So what has been developed within Flexim, there's 2 kind of ways to combat this. Within Flexim, we have developed something called disturbance correction, where work was done with the National Meteorology Institute in Germany, where they ran a number of tests on different disturbances, utilizing the meter on this extremely large rig to derive these disturbance correction factors that we can now apply on fixed meters for different types of disturbances, whether it's a 90-degree bend, out of plane bends, etc. And more are getting added to that as we progress. And what that means is we can then drop these kind of disturbance lengths down to 2D on certain things like reducers and double plane bends and things like that. Okay, so that's one aspect that's really helped with the concept of up and downstream lengths. The other way and more efficient and can be kind of a basic way to go about this, and from a clamp-on perspective, is adding more paths. So if we go back and think again about what we're trying to do with clamp-on, is that we have a beam running through the pipe on a cross section, and what those figures on the bottom they're showing is an averaged profile in the middle there on A, versus C, where it's after a 90-degree bend, where the high flow has been forced to the top side of the pipe. And as you can see, on a standard cross section, we're missing that top end higher rate flow. So that what we were trying to do is encompass more of the pipe to reduce the uncertainty within it. So what you can see here is a basic straight through measurement on the far left, through to a reflect arrangement where you're passing through the medium twice. So now we have two paths of averaging on that pipe. Moving on to adding in more channels. So as we add more channels, we add more coverage over that cross-sectional area. So not only are we covering it cross-sectionally in that diagram there, but also on the lengthwise plane as well. So you're building up more and more averaging of what's actually going on in the pipe to cover more potential with what's within the pipe. So you're reducing that uncertainty of what you're reading. So and then we actually go up to a 4-channel meter for really complex applications as well, and for larger pipes as well, so we get good coverage. And it's always that cost basis of, uncertainty versus cost is the typical thing. Each meter is calibrated and separately calibrated. So transducers and the transmitter are separately calibrated. So that does mean that you can plug in it, if for any reason you had a transducer transducer go down, you can remove that and plug in a new one without any problem at all. And then the big one is, how do I trust it? You know, there's always this concept around clamp-on. It doesn't work, or how do I believe what the flow is telling me? Well, there are certain specifics that we look for within clamp-on technology to give us the confidence in what we're reading. And we start off with this green, amber, red system that we have, looking at specific diagnostics, which are the on the left there, the SCNR, the SNR, and the gain. Amplitude is also related to gain there. So we are looking for good values in those three values, which highlight how good the connection is with the pipe, what the type, how good the signal strength is going through the medium itself, you know, and if there's any potential issues around that. Once we're happy with those diagnostics are good, we then look at the other thing there, which is sound speed. So this is really, really key. It is possible to have good diagnostics but have a wrong sound speed. So this is really key and gives us good confidence that what we're seeing is the right medium. So this example itself is for steam. So this was done on a 142 mil steam pipe. And what this is telling me is that we've set on the meter here with these parameters, and at those parameters, it's telling me that our fluid sound speed should be 497.09 meters per second. And actually what you can see down the bottom is the meter measured 505.6. So we are very, very close in terms of our meters per second around what we should be seeing. And that could be put down to maybe a slight temperature misbalance or a little bit of moisture in the steam, etc. But yeah, a few meters per second is extremely good. What can happen is if, for example, you're on a gas and you're getting the meter, the sound is going around the pipe rather than through the medium, you might be getting sound speeds up to 2000 odd. So that would say that your diagnostics are really good. However, the speed of sound would be wrong, and therefore the measurement will be incorrect as well. So understanding the speed of sound of what you're looking for is again really important and a really good basis to give you confidence in what you're reading. And then lastly, up here right on the right hand corner, we have a signal snap that shows us that we've got really good signal, no noise on there, and a really good shape, and there's more that can be done with those. But yeah, these diagnostics really help justify what we can and can't see, and sometimes lead to more as well. You know, sometimes it can highlight other things that are going on with the pipe. So over time, you might see a reduction in one of these values, which could point to things like build up and things like that. So what about going forward into you know, you've got this meter in situ, and 6 months or a year later you want to verify it, make sure it's still working okay. Well, within that meter there is something called smart meter verification that we can run for you, that basically takes a fingerprint of all those diagnostical data, is stored on the meter itself at installation, and then can be read back after your time frame. So whether that's 3 months, 6 months, a year, to make sure that there's been no change in those diagnostics, or if there has been a change, has it gone up, has it gone down, why? It will then reference and give you ideas of what could have happened if that has taken place. So like I said, if the SCNR value has dropped by 5 decibels over the last 6 months, then you know it might suggest is your connection okay? Have you potentially got buildup coming up inside the pipe? Those kind of things will be highlighted. What that does negate though is the needs to take things out of the line, take things off the line, stop process, and it's done as a live test. So yeah, it's a really smart, good way of making sure that the meter's still performing in the way it should do. So from our perspective, I guess, is these are just examples of us going and doing tests for customers on their sites. So whether that's a liquid test, gas test, or even steam tests, which these are showing. Left-hand side is water, but that's actually on a pre-stressed concrete pipe, which is quite a challenge. The middle one is compressed air, and the right-hand side is steam. Yeah, we're more than happy to come out, prove the concept, show you what we can do with our meter, and it's a great way for you to understand the power and what's achievable, not achievable, utilizing clamp-on. What we can send out to you if people are interested is there are specific applicational booklets for different industries, whether that's power, chems, water, utilities, with specific case examples of applications that have been done, whether that's a cooling water application or a leak detection system or an acid line, things like that, or even concentration. So yeah, if any of those booklets would be of interest to anybody, then of course we can get in touch and we can send those out to you. And that's really that was all we had to share with you today. If you have any questions, I'd be glad to try and answer them for you.
Yeah, thank you, Simon. That was it was really informative. I did see a couple of hands come up. Peter Norman.